Let's go ahead and begin 243 notes. 243 notes. While we complete these examples, you want to keep this in mind. This is how we're going to estimate the rate of change from a graph. Step 1, we're going to determine the interval to be observed. Step 2, we're going to identify x1, y1 as the starting point of the interval. Step 3, we're going to identify x2, y2 as the ending point of the interval. Step 4, we're going to substitute these two ordered pairs into the slope formula to calculate the rate of change, which we should be familiar with this step as you had to complete this in your previous notes. And then step 5, the result is the estimated rate of change for the interval between the 2 points identified. Example 1, the following graph compares the distance a small motor scooter can travel in miles as a function of the number of gallons of fuel used. What is the rate of change for this scenario? Looking at our steps here, these are the same steps that we just went through. Step 1, we're going to determine the interval to be observed. Looking at this graph, we can see that this is a straight line, letting us know that this is linear. A graph that is linear, we're going to have a constant rate of change. What this means is I can pick any 2 points that lie on this line, and when I determine the rate of rain or the rate of change, it's going to be the same. So if I pick 2 points on this line and I determine the rate of change, it's going to be the same as if I picked 2 other points on the exact same line and determined that rate of change. Step 2, we're going to choose the initial point of the interval. When I choose the initial point, all right, we can choose any point, but the point that I like to look at is our y-intercept, so where my graph is crossing my y-axis, because usually in these types of problems, you can tell the exact coordinates of that point. And from this, I can tell this is 0, 1.5. Step 3, we're going to choose an endpoint. Again, here you can pick any point that lies on this line. You want to pick a point where you can tell the exact coordinates. So I'm actually going to pick this point right here, which is 20, 1.3. Using these 2 points, we're going to determine the rate of change of this problem. Substitute these 2 points in the slope formula to calculate the rate of change like we just talked about. Before we can substitute these into the formula, we need to identify our x1, y1, x2, y2. And now we're going to go ahead and write our formula to remind us how to determine the rate of change. That is y2 minus y1 over x2 minus x1, your change in y over your change in x. We're going to go ahead and substitute our known values that we identified into our formula. So my y2 is going to be 1.3. We're going to take 1.3 minus our y1, which is 1.5, over our x2 minus x1, which is going to be 20 minus 0. My numerator, the top of that fraction, 1.3 minus 1.5, is going to give us negative 0.2. Negative 0.2. In my denominator, I'm going to take 20 minus 0, which is going to give me 20. I take negative 0.2 and divide it by 20 in my calculator. I'm going to get negative 0.01. Negative 0.01. So what this means is the amount of fuel by 0.01, and then we need to have our units as well, but just to make note of this, it's decreasing because it's negative. All right, we ended up getting a negative 0.01. It's decreasing because it is negative here. And then by 0.01, what? Well, remember, our rate of change is our change in y over our change in x. our change in y over our change in x. So what I like to do is I like to go to my labels here. So we're talking about gallons per mile. Gallons per mile. Of fuel decreases by 0.01 gallons per mile. Jasper has invested an amount of money in a savings account. The following graph shows the value of his investment over a period of time. What is the rate of change for the interval from 1 to 3? And here we're dealing with years, so we're trying to find the rate of change from year 1 to year 3. To do that, we need to find our starting point and our ending point of this interval. Our starting point, we're going to go to 1 on our x-axis, and we're going to go up until it hits our line. And here we're going to have to estimate. Well, I know right between 400 and 600, that's going to be 500. And it's slightly above that. So I'm going to say our first point is 1, comma, 500 point. Let's find our ending point of our interval. So we're going to go to 3 on our x-axis. We're going to go up till it hits our line. Out here. It looks like it hits right between 1,000 and 1,200, which is going to leave us at 3, comma, 1,100. 2 points to determine our rate of change for this problem. So this is going to be our x1, this is our y1, this is our x2, this is our y2. We're going to use our rate of change formula, which is y2 minus y1, our change in y, over our change in x. X2 minus x1. Find each value within each ordered pair. We're going to go ahead and substitute these in. My y2 is 1,100 minus my y1, which is 550, over my x2, which is 3, minus my x1, which is 1. (1,100 minus 550 is going to give us 550. 3 minus 1 is going to give us 2. If I take 550 divided by 2, that's going to give me 275. And given this problem, we need to make sense of what does this 275 represent. So we're dealing with our rate of change over the interval from 1 to 3. So we're going to write this. The rate of change from 1 to 3. So from year 1 to year 3. Our answer that we just determined, 275, for rate of change, it is your change in y over your change in x. So here we're dealing with $275 per year. The rate of change from year 1 to year 3 is $275 every year. Example 3. Jasper is curious about how the rate of change for his savings account differs from the interval from 3 to 6. So what we're looking at is from year 3 to year 6 this time. We're dealing with the same graph from our previous example. They want to know from our interval from 3 to 6. So at 3, we know we're at 1,100 because of our last example. At 6, we need to look at what my ordered pair is for this point. I know my y-axis is going by 200s. So this means this would bring me from 3,000 to 3,200. If I draw a line from my y-axis to that point, it looks like it's hitting right in the middle of 3,200 and 3,000, which would bring us to 3,100. From here, we need to identify x1, y1, x2, y2, and we're going to substitute this into our rate of change formula. Which is my change in y over my change in x. If I substitute my known values in that we've just identified, we're going to have 3,100 minus 1,100 over 6 minus 3. When I calculate 3,100 minus 1,100, that's going to bring me to 2,000. Then when we have 6 over 3, or 6 minus 3, excuse me, that's going to give us 3. If I take 2,000 divided by 3 in my calculator, I'm going to get 666.6666 repeating. When you round, you need to think about the units you're dealing with. Here, we're talking about money per year. So we're talking about the amount of money per year. Well, we're going to want to round to the nearest hundreds place. So that's second decimal place. So I'm going to use my approximation symbol because we're going to round here. 666.666, I want to round to the second decimal place. So this 6 is going to make this 6 become a 7. So I'm going to erase these. I'm going to put 666.67. And again, for this problem, we're dealing with the amount of money per year. So from year 3 to year 6, there's approximately $666.67 per year. Now, they do want us to compare the difference between our two rate of changes for example 2 and example 3. Just by looking back at example 2, it says the rate of change from year 1 to year 3 is $275 per year. The rate of change for example 3 is from year 3 to year 6 is approximately $666.67 per year. So from this, we can see that the rate of change is greater, meaning also that it's steeper when we're comparing the two. So from here, we can say the rate of change from 3 to 6, meaning from year 3 to year 6, is much steeper than the interval from year 1 to year 3. The rate of change from year 3 to year 6 is much steeper than the interval from year 1 to year 3.